What's going on, guys? Welcome to another episode with Everything EE. Today we're going to be talking about energy stored in a capacitor and running through this example here. I'm trying something new, writing all this stuff down. So I'm going to be kind of writing it out and then making it a bit smaller. So at the end of the video, hopefully we have like all the work on the video, and you guys don't have to go back and forth to see all of the work in one place. So let's see how this goes. The problem is that we have this 150 picofarad capacitor with the voltage across it that is described as VC. That's equal to 10t minus 25. So we have this first order voltage that is going across this capacitor. So we want to do three things. A is asking us to find the energy stored in the cap at t equals 15 seconds. B, determine the instant of time at which the energy has a value of 0. And then finally, we want to determine the change in energy between t equals 5 seconds and t equals 45 seconds. So let's get to it. Let's start with A. So with A, we want to find the energy stored in the cap at t equals 15 seconds. And so what we're going to do here is we're going to use an equation that we already know. The energy across a capacitor, and this is kind of similar to what we see in physics with kinetic energy, where we have the equation 1/2 mv squared, where m would be mass and v would be velocity. This is kind of following that suit, in where we have 1/2 c vc squared. Okay, so let's plug in for c and vc squared. We're gonna get 1/2. C is 150 picofarads, so that's 150, and the way we can write picofarads is times 10 to the minus 12. If that's confusing, don't let it be. This representation of picofarad is very common. All we're doing is showing that this 150 really has a bunch of zeros behind it, and it's down in the decimal area, in the decimal range. So don't let that confuse you. I'm just representing it so that we can just type it into our calculator. Okay, so that was C. Let's do V squared. We know that VC is 10 times T minus 25, so 10. And what's our T here? Well, they want to know what the energy stored is at T equals 15 seconds, so this is 15 minus 25 and squared. Okay, so we can go ahead and rewrite this as I'm going to change this half to 0.5 times 150 10 to the minus 12 times 10 times 15 is 150 minus 25. We get 125 squared. And then that's going to give us, our final answer is going to be 1.1719 times 10 to the minus 6. And our units are joules. Okay. So really this wasn't too bad as long as we remember our equation for energy in a capacitor. It's just 1/2 capacitance times voltage squared. Okay. All right, beautiful. So we've moved A up to the top right, and now we're moving on to B. That worked quite nicely, actually. So we're determining the instant of time at which the energy has a value of 0. So we know from A what our equation for energy is. And if we are defining what our energy is, which is in this case a value of 0, we can just use that equation and leave t as the unknown and solve to get at what time t does the energy end up being 0. So let's do that. We have the energy we want is 0. So remember, we're using this equation from A. This energy equals 1/2 CVC squared. So for WC, the energy, it's 0. And then we have 1/2 the capacitance, 150 times 10 to the negative 12 times V squared, which in this case, we're going to leave T in here. So it's 10T minus 25 squared. Okay, now we're going to solve for T. So we're going to have this term right here is going to cancel out. So we're going to have this right here. If we divided this out and we divided 0 by this term, we would get 0. So we're actually ending up with 10T minus 25. And, you know, this is squared, so we want this term to equal to 0. We want that to be equal to 0. And we can kind of not worry about that squared part. And if we wanted to take it a step further, right, we got rid of this 1/2 C term that's circled in blue. And when we do that, we divide and we get 0 on the other side. We can also take the square root here and get rid of this square. And we would get the square root of 0 is just 0, because we would be taking the square root on both sides to get rid of that power of 2. So we are really just end up with 10T minus 25 equals 0. Okay, and now we just solve for T. And we subtract from both sides 25. I'm sorry, add. That's 10T equals 25. We divide both sides by 10. And then we get T equals 2.5 seconds. All right. Okay, now we got B up there. Let's finally get to C. And for this one, we just need to solve for the energy at each point in time and then take the difference, because we're looking for the delta between the two. So we will have WC at time T of 5, because we're looking at T equals 5 seconds. So that's going to be 0.5, the 1/2 C, which is 150 times 10 to the minus 12. And then V squared, which is going to be 10 times 5, because our T is 5, minus 25 squared. And what that's going to give us when we put it in our calculator is going to be 4.6875 times 10 to the negative 8. All right. So that's going to be one of our answers. Well, part of our answer. And then we need when T is equal to 45. So we want to find the energy when T equals 45. So we have our 1/2 C V squared, which is now 10 times 45 minus 25 squared. That's going to give us 1.3547 times 10 to the minus 5. Okay, now we just take the difference of the larger one minus the smaller one. So that will be, if this is our equation 2, we want to do 2 minus 1, because 2 is larger. That's going to give us 1.3547 times 10 to the minus 5 minus 4.6875 times 10 to the minus 8. And if we put that in our calculator, we will end up with 1.35 times 10 to the minus 5. Alright guys, thanks for watching, and please like and subscribe, and post below if you have any comments. Thanks.